that.
Mm-hmm.
Yeah. And then, and so let's just think about this for a second. And just think about this one for a second.
Okay.
Okay? So now what's happening? So this is what we're doing. We're plugging in some numbers, right?
Mm-hmm.
We're saying, okay, let A be 1. Just it's greater than 0, right? So A is 1. So what's H? Well, H is approaching 0, so let's let it be 1, because that's close to 0, right? Because its limit is 0. So when H is 1, is anything changing really? No. It's still, this function is going to equal -1. Right? Because 1 minus 1 minus 1, right? So I got 0 minus 1, which is -1, divided by 1. It just gets me back to that -1 here. But what happens when A gets bigger? When A's 10? And
10 minus 1. Right?
yeah. So 10 minus 1.
And then you're minusing the other.
So 10 minus 1 minus 10 squared, or 100, right? All over H, which is
Is 1.
1. So now with H being small, right, and A being bigger,
Mm-hmm.
then what occurs? Then we have a 100, -99, and then 1 squared, so -100, and then divided by 1 is -100. So now all of a sudden it's getting a little bigger, or should say a little smaller. Okay. So now what happens when
So
H becomes,
if A is 10 and H is 1, then you just get a -91.
if A is 10 and H is 1?
Yeah, because 10 minus 1 squared is the 9 minus the 100, because you got the 10 squared, which is the -91.
91.
Yeah,
Negative
over 1
91.
is negative
Okay.
91.
Thank you, thank you. So -91, but it's still bigger or smaller now, right? So now what if we put in 10 as H? And
Gets
10,
bigger.
what happens now? As these both get
It
bigger.
just gets, yeah.
So H becomes 100, so you have 100, and you have 10, so you got minus 90, minus 100, and what happens?
Minus 190.
Over
Okay, over 10,
10.
which would mean,
Negative 19.
yeah, okay? So it's staying negative, right? It's staying negative. Okay, what happens as H gets closer to 0 then? So nothing really is going on too much when it's this number bigger than 1, right? But what happens when that number becomes smaller than 1 but bigger than 0? So what happens at a half? When H is a half? So now let's look at A is 10, but H is a half. So now we're talking about minus a quarter, right? And now minus a quarter from 10, which is only 9 3/4, right? And then we minus another,
A is 10 and
A is 10. So we minus another 100
and H is a half.
from 9 1/4, and we got minus 90 or 90 3/4 or something like that. And then, but here's the kicker.
Assuming A is
Now when h is a half, right? What happens when we divide it is we multiply this by 2. So now this becomes a bigger number. So what happens when h gets really
Assuming
infinitely
A is
small? So this number gets really, really big. This number is going to get really, really, really small, right? As this gets closer and closer and closer and closer to 0, then this whole thing is going to go closer and closer and closer to negative infinity. Right? Because this 1/2 made that, all of a sudden made that bigger. Twice as big as it ever was before. And that's only at a half. That's the lowest number in the bottom. So now if we make it an 1/8, or if we make it a 1/10, it's going to get even bigger, right? And then we make it a millionth, it's going to get huge. And as we get closer to 1/infinity, as h is equal to 1/infinity, which is as small as you can get before it turns to nothing.
So it's
Right?
like the smaller than the bigger.
Yes. Well, the bigger number, but it's negative, right? So the number's getting bigger, but remember, it's a negative number, and
That's-
so
It's
it's becoming negative infinity. But on the other side of 0, what if we're approaching 0 from this way, from the negative side? So we're going over negative infinity. It changes that from a negative infinity going down to negative infinity to going
to a positive
up
infinity.
to positive infinity. So what's happening at the limit of h equals 0? When you're approaching 0 from the negative side, the closer it gets to 0, the closer this function gets to infinity. As soon as you pass 0 and you step over into the 1/infinity, you go from being at infinity to being at negative infinity. And where do you come back to? 1. Right? So if we were to graph this, as soon as we hit 0, there's nothing, right? Open circle. But as we're getting closer and closer and closer to h being, and let's think of h as being on the x value, right? As h being, so this is, the closer we get to negative, right here, the closer we get to infinity, right? Yeah, infinity. So we're way up here, and we're going to come down, right? And this is all within 1. And then all of a sudden at 1, we're at negative 1. 1 and negative 1, right? So at some point, we're coming to right here. Then we're going to come out like this. But as soon as we hit 0, though, as soon as we're on this side, right? Then all of a sudden now we come straight from down here at negative infinity. And what happens? So before, in fact, we didn't check what happens at negative 1. I'll bet at negative 1 this becomes negative, and guess what? This is actually going to meet here at 1. Right? But over here it meets at negative 1. So negative 1, and then it just kind of levels out and gets smaller.
What
So
is
the
it?
closer we get to 0 from the negative side, the closer we get to the positive infinity.
Yes.
And as soon as we get or go like past the 0, we stay at 1.
That's what it sounds like.
Well, we don't necessarily stay at 1 because remember there's a whole bunch of possibilities throughout here depending on what A is, right? If A was 1, then they stay kind of like this. If A was 10, then they go kind of like this. But the point is, what happens here. We're just asking what happens right here. And as we approach, no matter what happens, as we approach from either side of 0 to 0, what happens is this function goes, on the positive side, goes straight to negative infinity. But on the negative side, it goes straight to positive infinity. Because that's all we're asking about, is the limit as h approaches 0. And we're assuming that a stays positive. Why is that crucial, that a stays positive? Because then that's going to mess your whole, negative, positive infinity all up. Because if a was negative, then that would flip it. Right? So that's important that we label that a is greater than 0. It's going to be positive. Because no matter what happens, even though this stuff is, it goes all over the place because you're not sure what's going on, what we do know it goes on as we approach 0 is it goes off to negative and positive infinity. And it's weird because as we approach 0 from the negative side, it goes to positive infinity. But as we approach it from the positive side, it goes to negative infinity. So did you see how we had to kind of label, we had to kind of put in a half, and then think about what a half did. But before we put in the half at approaching that limit, we kind of took some numbers out here first, get kind of an estimate what's going on. Just an estimate. And then we start diving in towards the limit. And remember, the limit, a lot of the times, means that the bottom number is going to 0. The denominator is going to 0. Because as soon as it hits 0 in the denominator, it's null and void. It doesn't work. Okay? That was like 19 minutes. I'm going to probably cut out the beginning